The third type of miscellaneous equation we're going to look at is solving rational exponent equations. Rational exponent equations just really means that you have some kind of expression that's being raised to a rational exponent or a fractional exponent. Let's look at the steps. Number 1, or A, asks us to isolate the expression with the rational exponent. So you need to isolate or get this expression that you're raising to a power all by itself on one side of the equal sign. Step 2 says to, okay, we'll get rid of that rational exponent, so you have to raise both sides to the n over m power, which is really the reciprocal of whatever you've originally been raised to. There are two things that can happen here. If that original numerator is even, you're going to have to write a plus or a minus with the number after you raise both sides to the reciprocal power. If it's not, you don't need to write a plus or minus. So the only time the plus or minus has to be there is if your original m, or the original numerator, is even. And we'll talk about why that is within the example. Very last step is to check the solutions to make sure that they work. Again, that is important within the rational exponent equations. So let's take a look at some of the examples. Our very first example is example 5, which is x squared plus 6x minus 7 raised to the 3/2 equals 27. So step 1, isolate what you're raising to a rational exponent. Well, is what I'm raising to the rational exponent of 3/2 all by itself on one side of the equal sign? It sure is, so A is done. Second thing, you need to raise both sides to the reciprocal power. Well, what am I currently raising it to? I'm currently raising it to the 3/2, so the reciprocal of 3/2 is going to be 2/3. So I'm going to have to raise both sides to the 2/3 power. So I would have that x squared plus 6x minus 7 to the 3/2 raised to the 2/3. That's going to equal 27 raised to the 2/3. Now it tells you, okay, be careful if m is even. Well, m, remember, is the original numerator. Is that an even number? No, so I don't have to worry about that. M is odd, I don't need a plus or minus. So now I just need to simplify this stuff and solve. Well, over here on the left-hand side, x squared plus 6x minus 7 to the 3/2 raised to the 2/3, these will just cancel out because, again, power to power, we multiply. So 3/2 times 2/3 would just be 1, so it just cancels itself out. And I'm left with my x squared plus 6x minus 7 equals, now we have to take 27 to the 2/3 power. Right, I want us to recall this just in case we've forgotten it from intermediate algebra or from high school before. 27 to the 2/3, we really say that that's like a raised to the m over n. Well, that equals the nth root of a raised to the m power. So the bottom, or the denominator, is your root, and the top, or the numerator, is the power that you raise it to. So 27 to the 2/3 means the cubed root of 27, remember the denominator is your root, raised to the second power, because the numerator is the power that you raise it to. So let's work out the cubed root of 27 squared. Well, the cubed root of 27 is 3, because 3 times 3 times 3 is 27. And I have 3 squared. Well, 3 squared is 9. So I end up with x squared plus 6x minus 7 is equal to 9. All right, well, what type of equation is this? Well, this is a quadratic. Remember, with quadratic equations, we have to get them equal to 0, and either factor, complete the square, or use the quadratic formula. So I'm going to subtract 9 from both sides and see what happens. I have x squared plus 6x minus 16 is equal to 0. Well, I can factor this, so I'm going to go ahead and factor it. It doesn't have a GCF, so let's just work it this way. All right, so we have x and x, only things that multiply to x squared. Then I need to multiply to 16 and then subtract to a positive 6. So that's 2 and 8. It's got to be a positive 8 and a negative 2. I'm going to just check this in my head. We have x squared plus 8x minus 2x gives me my 6x that I needed minus 16. Great. Solve both of them. I get x is equal to 2 and x is equal to negative 8. Last step says to check. So let's go ahead and check. We have to check and make sure that this actually works. So I'm going to start by checking x equal 2. And what I need to do is I need to input it, or place it back into the original up here. It's x squared plus 6x minus 7. So I write 2 squared plus 6 times 2 minus 7. And it was raised to the 3 halves, and we need to figure out, does that actually, with a question mark, equal 27? Well, I don't know. Let's work this out. Well, 2 squared is 4, so I have 4 plus 6 times 2 is 12 minus 7 raised to the 3 halves. I'm still trying to figure out if this equals 27. Well, 4 plus 12 is 16 minus 7 is 9. So this is 9 raised to the 3 halves power. Still trying to figure out if that equals 27. Remember, 9 to the 3 halves means the square root of 9 cubed, right? The square root, because that's your index of 9, and then cubed because the numerator is the exponent that you're raising it to. So let's see, the square root of 9 is 3, and 3 cubed, does that equal 27? Yep, that works out. So x equal 2 is a good answer. Now I need to check x equal negative 8. Let's go ahead and do that. So I have negative 8 squared plus 6 times negative 8 minus 7, raising this to the 3 halves, trying to figure out if it actually equals 27. Well, I'm going to kind of do this all in one step just to make it a little easier because I'm running out of room. So negative 8 squared would be 64. 64, and then 8 times 6 is going to be 48. So 64 minus 48 minus 7. So if you were to work all this out, this would be 64 minus 48 minus 7, and that's going to give us 9. Well, I need to figure out, does 9 to the 3 halves give me 27? Wasn't that the exact same thing that I had over here? And did that work? Yes. So this is going to check out as well. So both of the answers work. So the solution set for this particular problem is both 2 and negative 8. Again, what did we do? We isolate, we raise to the reciprocal power, and then we just solve and check. Let's look at example 6. Step 1, isolate. Well, am I isolated? Yes, I am. I'm just going to give you an example of something that wouldn't be isolated. Let's say that I had 2 times x plus 5 raised to the 2/5 minus 1 is equal to 17. Do you notice now that the expression that I'm raising to the rational exponent is not isolated? I'm subtracting 1 from it, I'm multiplying 2 to it. So this I would have to isolate first. But the expression here, this x plus 5 here, is already isolated, so I wouldn't have to do that step. This is an example of something that would have to be isolated. But our current example, example 6, doesn't need to. So it tells us then, next step, raise to the reciprocal power. Well, the reciprocal power, so the reciprocal of 2/5, is 5 halves. So I have to raise both sides to the 5 halves power. So I have x plus 5 raised to the 2/5 equals 9 raised to the 5 halves. Well, let's clean up here. X plus 5 to the 2/5, we cancel here because 5's cancel, 2's cancel, and that would just be 1. I have x plus 5 equals, all right, well, I need to take 9 to the 5 halves, but remember within this step, if the original numerator is even, you have to write a plus or minus with the number. So my original numerator here too is an even number. So on the right hand side, I have to write plus or minus, and then 9 to the 5 halves is really the square root of 9 to the 5th power. Now, the reason that we have to write the plus or minus here is, notice when I wrote 9 to the 5 halves, I had to take the square root of 9. And remember back in the section that dealt with quadratic equations, if you took the square root of an equation to solve it, you had to write plus or minus. Well, because the reciprocal will have that even number down there, you're taking either the square root of the 4th root or the 6th roots, you have to write a plus or minus with those numbers. So continue to work this out. The square root of 9 is 3. And now we have to raise 3 to the 5th power. And so 3 to the 5th is 243. So I have x plus 5 is equal to plus or minus 243. Pretty number? Sure is. So I split into 2 different equations. We have x plus 5 equals positive 243. That's the top. Bottom, x plus 5 equals negative 243. We'll go ahead and finish solving. Here x is equal to 238. And on the right, x would equal negative 248. So what do we have to do now? We have to check. So let's go ahead and check. Let's check x equal 238. Instead of x, I write 238 plus 5, and then I'm raising it to the 2/5 power, and I have to figure out, does this actually give me 9? Well, I don't know. Let's find out. Well, 238 plus 5 is 243. Raising it to the 2/5 power, still trying to figure out if it's 9. Well, 243 to the 2/5 is really the fifth root of 243 quantity squared. Well, the fifth root of 243, well, remember, I just figured out that 3 to the fifth power is 243. So the fifth root of 243 has to be 3. So we have 3 squared. Does this equal 9? It does. Means 238 checks out just perfectly as an answer. Let's try the other one of negative 248. So I'm going to check x equal negative 248. Same thing, plug it into the original equation and figure out if it works. So negative 248 plus 5 raised to the 2/5, does that actually give us 9? Well, negative 248 plus 5 is negative 243. Still raising that to the 5/5 and trying to figure out if that's 9. Well, let's see here. So this is the fifth root of negative 243 squared. Does that give us 9? The fifth root of negative 243 would be negative 3. Does negative 3 squared give 9? It does. That answer works. So the solution set for this particular problem is both answers, which is 238 and negative 248. So with rational exponent equations, again, the biggest thing to watch out for is when do I put a plus or minus, and you're only going to put a plus or minus when the original numerator was even. The next video is going to talk about equations in quadratic form.